All right, I'm going to be talking about, these are sedimentary rocks. This rock that we have in our hand is not quite rock yet. This is in between rock. It's called lignite, and it's the precursor to coal. So a bunch of dead plants died someplace and they came together. After time and compression, it becomes tabular and forms into this, which is coal. Now, if sea animals die, this one is chalk, and this has got fossils in it and all sorts of stuff. Now, chalk, these are algae that fall to the bottom of the ocean. Now, on the bottom of the ocean, there will be muds that form, and this is a mudstone with ripple marks across the top of it. Now, if rocks break down and break up, that's what this is. This is a conglomerate. Now, as those layers, they can be laid down very quickly and very finely with very fine layers. Every one of those layers is probably a year. So there's probably about 100 years in my hand right there. Now, when animals die in the mud, like over here, you may see on the top, this animal that is the dark spot here was an animal. And now this died on that. It formed around it and filled this void that became a rock. Now, as seashells die, forming more seashells, this is almost a limestone. This one is limestone here. This one's just dead sea animals. Now, here's another dead sea animal that died in the soil, filled in around it. And here you have a beautiful fossil of a more complex sea animal in a concretion. This one is a nice fossil right here. Now, this is limestone, and I don't know what the fossil is. It's pretty hard to tell. Now, if trees die, they'll get replaced, and this is petrified wood. Now, this is the hardest of your sedimentary family, and that's a geode, and it's quartz crystals. Now, a river bed comes along, dumps out into a plain, and then it glues itself together with dying organic matter, and that's what this one is. And you can see a lot of iron in this. This is going to form into an iron mineral, and you'll see that over on the other side as it hardens and gets compressed. Now we're into the first of the metamorphics. Now the metamorphics, this one is slate. It's a nice chunk of slate. There's even a few fossils that are on the top of it, and you will see some fossils within a metamorphics. Now, as it gets more and more compressed, it gets to be a little bit more shiny, and this is a schist. Now, it becomes more and more together, and then this got pushed together in softer sediments and came as a large crystal of gypsum. Now, eventually, it could end up looking like this. And this one's almost a gneiss. And gneiss is a layered hard rock, and you can see some hard veins in this. Now, crystals will start to grow out of it, and possibly you'll see crystals that look like this. Now, if I took acid and tested those, that are probably calcite crystals. The green is some form of mica or, not mica, copper. That's copper mineral coming out. Now, as you compress it even further, you will get even more minerals. And this one's probably marcasite or something along those lines, which is in the family of manganese minerals. Now, you can also metamorphose volcanic rock. Now, this used to be basalt, and then you'll notice that it's turning green, and the green in this is because it's called greenstone. It's metamorphic basalt. You'll see bigger crystals growing in this. This is rosy quartz. Now, if you remember that one before from the sedimentaries with the iron in it, well, if you put that under enough pressure, it can grow into this. And this is called specular hematite, which is in a metamorphic deposit of rock. And that's just a beautiful rock. Now, we go over to the igneous rocks. Now, this one here was molten, but it cooled slowly. So it's kind of in between volcanic and igneous, plutonic. So this one here is a volcanic, almost a granitic, dioritic crystal form of basalt. Now here's the vesicular basalt. Now this one, how the difference is, even though this one looks the same as that one, because of its lightness, this is pumice. So this is actually volcanic glass. Now, volcanic glass, so this came out of the earth and cooled rapidly. Now this one's normal volcanic glass called obsidian. And then here's the prettier version, which is called mahogany obsidian. This is a nice chunk of mahogany obsidian. This is probably from down at the Newberry Crater in Oregon. Now, if the molten rock doesn't make it to the surface and it cools underneath the earth, that's what the granite family is. And here's another granite. And that's a granite family. And those are all the rocks in the rock cycle. So from over here at sedimentary, through to metamorphic, through to igneous, and the plutonics that stayed underneath the earth, which were igneous.